Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes. Good
Okay.
evening, ma'am.
Today I am trying my camera to on, but I don't know the camera. I'm not able to on it. Maybe some problem is there. So yeah, without
Madam, there are two cameras there. We can use alternate camera also.
uh, see, I am trying to start the on the camera, but I don't know why it's not showing. It's okay, let's start. Maybe I can try this one if it's working. OBS version. Still not working. I don't know. Maybe some settings required. Oh, that is on now. Yeah, I think it's okay. Let's start the session on the recording. Okay, recording is on. So welcome everyone to the NPTEL course on novel technologies for food processing and shelf life extension. So the course instructor is Professor H.N. Mishra, and he's from Agriculture and Food Engineering Department, IIT Kharagpur. I am Shikha Sharma, and I'm a research scholar in the Department of Chemical Engineering, IIT Guwahati. I am TA for this course, and I'm mainly trying to solve the practice problems regarding each week. So now we have week 5, which is on the topic food extrusion technology, ready to eat snack food, then texturized vegetable proteins, rice and dal analogs. So I hope all of you have gone through the 5 lecture videos for week 5 provided by Professor Mishra. And if you have any doubt regarding it, please you can ask me. And in this live interaction session, we will be covering mainly the freeze drying, food extrusion technology, texturized vegetable proteins. On these 3 topics, we will be solving the practice problems and we will be discussing the concepts behind uh, on these topics. So if you have any doubt, you please ask uh, if you are not able to understand the practice problem questions, so you can ask, and also regarding the lecture videos. So yes, let's start with the today's first question, which is about these. We have 3 statements: statement 1, statement 2, and statement 3. So out of these statements, accurate we need to find which is true or accurate for freeze drying. So statement 1 says that about the sublimation front. So the sublimation front, also known as a transition zone, is the boundary between the frozen and dry zones. Statement 2 is saying during heat transfer through the frozen layer, heat moves from outside to inside, while the mass transfer occurs from inside to outside. And statement 3 says the speed of heat transfer is influenced by both the thickness and thermal conductivity of the ice layer. So we need to tell which option is true for freeze drying.
Option 1 and 3 can be, ma'am. 1, 2,
Okay,
and 3.
so today we have till now 31 students joined, right? Okay.
All three are correct.
Ma'am, option D.
C.
Option C, option C, ma'am.
Option 1, madam. 1 and 2.
So we have option 1 and 2, C and D or B. Somebody said D or
It's
B?
D.
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 No, no, D,
D.
ma'am. D. 1, 2, 3.
Okay.
Yes.
D.
So we get these options as till now, which everyone is saying correct. So anyone else? This camera is not showing. Yes. So let's discuss. The option C is correct. So why option C is correct and why others, like it is saying 1 and 3 correct statement, but 2 is a wrong statement. Let's see why 2 is a wrong statement. So usually we know that freeze drying is like the basic concept of freeze drying is like we let's discuss first and then we will understand why these options are correct or incorrect. So the freeze drying, which is also known as lyophilization, is basically it, we dry our food product using the freeze drying. In that, what happens, there is a crystallization of the solvent or the suspension medium at a low temperatures, and then sublimation. Sublimation means from ice, because we are putting the food product at low temperature, which crystallizes the ice forms, and then from ice to directly water is like from the ice to vapor is converted. So that means sublimation process happens, and in that vapor phase comes, so water removes from ice to vapor directly. And mostly the freeze dried products, they have final moisture content less than 10%. So this method is used to produce stable substances that remains unchanged after reconstitution with water. If we reconstitute with the water, it remains unchanged, it gets its original shape again. So all the ice, the water which is in the form of the free water and some bound water, they will be in the ice form, and through the freeze drying process we can able to remove all the free water and some of the bound water. Mainly three steps happen in the freeze drying. The first is freezing of the product at the atmospheric pressure. Then there is primary drying, in which there is the freeze drying process happens, where ice is converted to water vapor, which means ice sublimation happens at the lower pressure or at the vacuum. At the vacuum, what happens? The boiling point of the water it reduces, so it helps in the process of sublimation and faster removal of the water from the product. Second, drying, and after that second drying happens. In that, desorption drying is like after freeze drying, proper freeze drying, the method it food product follows is desorption drying, in which mostly the bound water it removes from the food product, and final moisture content or final humidity is achieved, or final drying is achieved. Like we can see in the picture on the left hand side is a picture of the freeze drying process, where we provide heat through the method of conduction to the food product. This is our food product, which is placed on uh, some metal, and that metal is providing the heat through the method of conduction. So after getting the heat, and this is all happening in the vacuum chamber. So in the vacuum and mild heat, it the water evaporates from the ice to directly water vapor, and water removes out from the product. As per the water phase diagram, if we see, so what happens? Water, it is first converted into the ice. We reduce the temperature at the atmospheric pressure. After that, what happens? The pressure is in the freeze drying equipment, the vacuum is there, so it reduces the pressure, and the vacuum condition it reaches, and due to the vacuum, and then heating, mild heating will be there, which helps in removing of the water, and water converts into the ice to directly steam. So sublimation happens. This is our freeze drying process. So in the question, it was saying about the sublimation front, about the heat and the mass transfer, and about the rate of the heat transfer process. So what is sublimation front? As we can see in the picture on the left, this product, in this is the whole product, this is the frozen, this part is the frozen part, and this is the dried part. So the gap, this boundary is the sublimation front. So sublimation front is also known as the transition zone, is the interface between the frozen zone and the dry zone. In the so first option is saying that sublimation front, that the sublimation front is also known as the transition zone, and it is the boundary between the frozen and the dry zones, which is correct, right? Because this is our sublimation front between the frozen and the dry zone. So first option is saying true. Then second is saying that in the heat transfer through the frozen layer, this is our frozen layer. So when there is a heat transfer happens, so what happens? Heat which is which is transferred from the metal to frozen material by the help of conduction, which is like from hotter zone to cold region it is transferred, and mass is transferring. Mass means our moisture. So the food product is having the moisture which is transferring. So it is transferring, like first it is transferring from the two methods. One is the diffusion. So diffusion is happening, and second is phase changing. Phase changing means ice is converting into the water vapor, right? and then it is diffusing from the higher concentration to the lower concentration. So higher concentration is in our food product and lower concentration is in the atmosphere. And this transfer, it both takes place from inside to outside. From inside to outside it is happening, like moisture is removing from the product to the atmosphere, which is inside to outside. Also, if we see the heat, so here the frozen product is like the frozen product is, it gets the temperature, and then the ice is converted into the water vapor. So it is also like taking place from inside to outside. So the option second, the statement second, it is saying that the heat transfer through the frozen layer, here in the frozen layer if we talk about, then heat moves from outside to inside, whereas heat is moving from inside to outside in the frozen layer. Then mass is transferring from inside to outside, from the product to the atmosphere. So this is saying incorrect. Third statement, about the third statement, since we know that the rate of the heat transfer is basically following the Fourier's law of heat conduction, where the heat, the rate of heat transfer, it is directly proportional to the thermal conductivity of the ice, then cross sectional area A, and then cross sectional area through heat is being transferred, and then temperature difference delta T dt, temperature gradient between the heating surface and the frozen layer, and inversely proportional to the thickness of the frozen layer. So this is our formula, and it is saying that the statement 3 is saying that the rate of heat transfer, it is it influences like it is indirectly proportional to the thickness, so and directly proportional to the thermal conductivity of the ice layer. So it is depending. So it is also true. So option C is correct here, not the A and D. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. So yes, next question is on the, again the freeze drying, that the complete quantity of heat needed in the initial stage, which is the primary stage of freeze drying, encompasses the heat of the sublimation, vaporization, enthalpy, and specific heat. It is a very simple question. Yes, please.
Latent of heat of sublimation. Option A.
Latent heat of
Option A.
sublimation.
Yes,
Option
ma'am.
A.
Yeah, ma'am.
Let's see how many people joined. 38. Today attendance is very less. Okay. So let's see the
Option A,
answer.
madam. Option A, latent heat of
Option A.
sublimation.
Yes. So you are true. It's latent heat or sublimation. So when there is a primary drying process happens in the freeze drying, the pressure is lowered, which is vacuum, and the heat is given to the product through the conduction mode, and ice sublimation process happens. So since ice sublimation process is happening, so the amount of heat necessary is calculated using the latent heat of sublimation of the sublimating molecules. which is water. Molar heat, the latent heat of sublimation definition is the more, if someone like is confused, just for the information, but I know you all know, the molar heat or enthalpy of sublimation is the amount of the energy that must be added to a mole of the solid at the constant pressure to turn it directly into the gases without passing through the phase of the liquid phase. So it is Q equals to latent heat of sublimation is equals to, it is equals to mass into में latent heat of sublimation. So everyone is correct. Latent heat of sublimation. Next question. Let's discuss among the given options which mode of heat transfer is not possible in vacuum freeze drying. So we have heat and mass transfer and which is not possible. So heat and mass transfer occurring through the same path but in the opposite direction. B is heat transfer taking place through the frozen layer and mass transfer through the dry layer. Third is heat and mass transfer proceeding along the same path in the same direction. D is generation of heat within the frozen layer. So not possible in the vacuum freeze drying. So
Option B,
we,
madam.
yes, option B, one. Another
Option B.
people,
Option B.
option B,
Option C.
option C.
Option B, ma'am.
Option B. Many people are saying B.
Option B, ma'am.
So the people who are saying B, can you please help us to understand why option B you are like saying option B is correct? Anyone? But option C is correct actually. That the heat and the mass transfer proceeding along the same path in the same direction is wrong. It's not possible. So usually,
But in the first question, ma'am, you told कि heat transfer and mass transfer occurs from inside to outside, right?
hmm, hmm, hmm.
So it is in the same direction.
So there are three conditions we have usually, like this. If you have like gone through the lecture video, there is one section where this graph, oh sorry, this diagram is there. Can you able to recognize? Like what happens?
Yeah.
There are actually three possible modes of heat transfer in the vacuum freeze drying when we are doing vacuum freeze drying. Okay. So what happened in the first one statement is saying that heat transfer and the mass transfer, it takes place the same path through the dry layer but in the opposite directions. When there is in the in the diagram, if we see B diagram, this one, so what happens, he this, if we see the dry layer, this is the dry layer, this is frozen layer, this dashed line is frozen layer, and then is dry layer. So what is happening in this part, if we see, this is the mass transfer and this is mass transfer. Okay, and heat transfer is this arrow, if we see from the arrow. So what is happening, so when we talk about the like dry layer, then heat and mass transfer, it follows the same path but in the opposite direction, because here from both side heat is going in the frozen layer and moisture is removing towards the atmosphere. So the direction is opposite. And if we talk about the rate of heat transfer in this process, so the rate of heat transfer to the sublimation front depends on the thickness and the area of the food, as well as the thermal conductivity of the dry layer and the temperature difference between the surface of the food and the ice front. So option A is correct. About option second, which is heat transfer through the frozen layer. So this is our frozen layer, the diagram A. This is our frozen layer. In this, heat transfer is through the and mass transfer is through the same direction. It is following the it is the heat transfer through the frozen layer is happening because heat is going in the frozen part and moisture is going from the frozen part to the dry part, it is going and then to the atmosphere. So mass transfer is happening through the dry layer. And in this case, the rate of heat transfer is depending on the thickness and thermal conductivity of the ice layer. And option second is correct because heat is transferring through the frozen layer while moisture is transferring to the from the from the dry layer then to the atmosphere. And this third picture is telling when we are doing microwave heating. So heat generation is happening within the frozen layer. In the frozen layer, inside this heat is generation. So internal heat is generating. That's why we are saying that generation of heat which is within the frozen layer. So option 3 is also correct. And in this process, the heat transfer, the rate of heat transfer, it is not influenced by the thermal conductivity of the dry and the frozen layer and also the thickness of the dry layer. And the option C is wrong because heat and mass transfer both is occurring in the same path and same direction, which is not feasible. Are you okay with the clarification?
Ma'am, in the first question, any specific kind of freezing was mentioned? Like here it is vacuum freeze drying.
Yes. So usually freeze drying happens in the vacuum condition. But we are talking about general lyophilization method.
Okay.
Yes. So also if you see in this, it is heat transfer through the frozen layer. So we need to consider when heat is like this in this such questions, please see the rate of heat transfer is asking in which layer, the dry layer, the frozen layer. We need to understand that. Usually, if in this condition also, if you see the product is there on the shelf, we are keeping it on the contacting the food material on in the contact with the conduction material. So also in this, if we are talking about, we are providing heat through another medium. Usually, like in the vacuum, if we do so in the vacuum, even at the atmospheric temperature, it like the vacuum is around like created like the vacuum condition is like that even at the room temperature the water starts evaporating. Here we are talking also, if you see here in this question we are talking about like the from the dry layer how moisture is like which path it is following. Now okay about this question's explanation, or you have doubt still?
Ma'am, but in figure 8 showing it's traveling in the same direction.
A is saying
Heat and mass is traveling in the same direction in figure A.
in figure A it is saying that in the dry layer, that is what I am saying, in the dry layer if we talk about, then mass is like mass transfer happens. It is just saying, it is saying just mass transfer happens, and it is saying in the heat transfer happens in this frozen layer. So it is heat will go in the frozen layer, so the direction is like this, and moisture is going out. It is here it is not talking about the direction. Also it is just talking about one direction. If you consider as a whole product, then both side we will get the heat from out. Like if a product is there which is having some dry layer in between frozen layer and then again dry layer, so heat will come from both side. Even on the if it is a rectangular product, the heat will come from the all four side, right? Like this. So here like this, like this, and moisture will go out. So from all direction moisture is going out, which is in opposite direction.
Okay. But then why it was not true in the first question, the earlier slide?
So earlier slide it was saying, second option it was saying that the during the heat transfer through the frozen layer, the heat moves from outside to inside, while mass transfer occurs from inside to outside. So actually it is considering that if a product is frozen like this, and if we are heating it, like if it is in contact with something and it is heating, so it's obviously its temperature is more, so product will go, the heat will go from like this, the in this direction, from the higher temperature to the lower temperature, because the which part is like touching the any conduction medium, so from that part will be at the higher temperature and it will go from like this, right, from
Yeah,
higher
yeah.
to lower.
But in both the questions, there was no diagram given. So how will we conclude?
uh, yes, you are saying correct that diagram is not given, but we need to, like if there is the heat transfer in the like which layer is there, if it's a dry layer, if it's a frozen layer, from that we can understand why, like what kind of change is happening, because here it's saying through the frozen layer, if you say see, and here it is through the frozen layer, if you say from like frozen layer it is asking, and in this question it is asking through, like here through the same, here it's dry layer, it is this question is talking about the dry layer. Usually this is the usually if the question asks, this is the, you take this case. Okay.
Okay.
Yeah, you take this case until it says that, specifically it mentions that from the frozen, like through the frozen layer. Okay.
Okay.
Yes.
Okay. So can we move to next question?
Okay, ma'am.
Thank you. So in the freeze drying, the cola's temperature impacts the product by keeping the structure intact, increasing the porosity, initiating shrinkage, retaining glassy state. What is cola's temperature in the case of freeze drying? Anyone?
C.
C. C is, so last in the last in this chat box, if you see, this is the link which I posted for the group, the where we group, the forum discussion forum link is this one in the chat box, which I here dropped the message after the previous class. Yes, so what is our option?
C, ma'am.
C, initiating shrinkage.
C.
Everyone is agreeing to C or any other option? So C is correct. What is actually cola's temperature? It is a critical point that impacts the structural integrity of the product during the drying process. The cola's temperature refers to the point at which the structure of the frozen material can no longer maintain its form due to the loss of the moisture and temperature change. So in freeze drying process, the temperature of the mobility of the drying layer is relatively low and its water content is also low, and the drying is conducted below the cola's temperature, at which there is the change in the structure. Also the porosity decreases, there is a loss of the glassy state, and the shrinkage is evident. So option C, because option D is saying retaining the glassy state, where there is a loss in the glassy state, and it is saying increasing the porosity, whereas it's decreasing of the porosity and keeping the structure intact, which is not correct because there is change in the structure. So option C is correct. Is it clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, so next is our one question. Let's solve. Everyone, please, to try to solve with me. In a freeze dryer, a food item with a slab thickness of 12 is dried from a moisture content of, there is a slab of food like this, which is having thickness of 12 mm. So we are drying it from a moisture content of 90 to 30 wet basis. The surface temperature of the slab is maintained at 30 degrees Celsius, while the frozen product is at minus 20 degree. Here it is minus 20, and the temperature here is 30 degree. Now, given that the latent heat of sublimation is 2840 kilojoule per kg, the thermal conductivity of the dry part of the product is 0.09 watt per meter Kelvin, and we are considering that the density of the frozen product is 1000 kg per meter cube. We need to calculate how much time is required to dry this product. Please try to solve. Okay, so we have the thickness of the food material, which is 12 mm. So 12 mm we are converting it into the meter, which is 12 into 10 to the power minus 3 meter. The initial moisture content is given as 90 wet basis. That means that if there is 90% of water in the wet basis, means that 90 gram of the water is there, and 10, if we talk about 100, let's suppose our product we are considering 100 grams, so 90 gram is the water and 10 gram is the dried material. If there is 90%, please can you mute? Yes, please can you mute? There is little noise at the background. So if there is, we are talking about 100 grams of the total product mass, then if there is 90% wet basis moisture content, that means 90 gram is having the water in that product, and only 10 gram is the dry material. So that means 90 gram of the water and 10 gram of the dry material. Also, we can say that if we talk about kg, then 90 kg water in 10 kg of dry material. If so, 9 kg of the moisture in 1 kg of the dried material. So, and final moisture content is 3% wet basis. That means in the 100 gram of the product, only 3% is water in the, like the final when we dry, only 3% is water, and 97% is, or 97 grams, it is dry matter. So 3 divided by 97, so 0. In 1 gram of dry material or in 1 kg of dry material, there is 0.03 gram or 0.03 kg of dry of water. Okay, is it clear how I am converting the moisture? So in first case, I am saying that 100 gram is my product. Out of that, 90% is water. So 90 gram is water and 10 gram is the dry material. So 90 by 10. So in per kg, in 1 kg of the dry material, 9 kg is the moisture. Whereas in the final, when the final moisture content is 3%, so 3 is water out of 100 and 97 is dry material. So 3 divided by 97, which is 0.03 kg of the moisture is there if we talk about per kg of the dry matter. Then we have the product surface temperature is 30 degrees Celsius given in the question. Like here it is given that 30 degree is the surface temperature and minus 20 is the frozen product temperature. So temperature of the frozen product is minus 20 and thermal conductivity of the dry part of product is 0.09 watt per meter Kelvin. Latent heat of sublimation is 2840 kilojoule per kg and density of the product is 1000 kg per meter cube. These all are given in the question and we need to calculate time required for drying. So as per the formula, time is equals to x square, which is the thickness of the food material square into its density, into the density of the frozen part, multiply m1 minus m2, which is the initial moisture content minus the final moisture content, into latent heat of sublimation, divide by 8 into thermal conductivity of the dry part of the product, then multiply the temperature gradient, which is the product surface temperature minus temperature of the frozen product. So we need to just put in this formula the time required for drying is equals to thickness. Thickness is given as 12 into 10 to the power minus 3 meter. So 12 into 10 to the power minus 3 meter and its square, then multiply by the density of the frozen part, which is 1000 kg per meter cube. Then m1 minus m2, the initial moisture minus the final moisture, which is 9 kg of the moisture per kg of the dry matter minus 0.03 kg of the moisture per kg of the dry matter. So 9 minus 0.03 into latent heat of sublimation, which is 2840 into 10 to the power 3 because it's kilojoule. So we are converting into joule. Divide by 8 into the thermal conductivity of the dry part of the product, which is 0.09 into the temperature gradient, which is the product surface temperature minus the temperature of the frozen product, which is minus 20. So 12 into 10 to the power minus 3 square, which is 144 into 10 to the power minus 6 into 1000 into 9 minus 0.03 is 8.97 into 2840 into 10 to the power 3 divide by 8 into 0.09 into 30 minus minus plus minus minus plus. So it is 30 plus 20. So T is equals to 144 into 10 to the power minus 6 into multiplying, this is the same 144 into 10 to the power minus 6, 10 to the power 3 plus 10 to the power 3 is 10 to the power 6. So we are putting 10 to the power 6 and 8.97 into 2840 is 2547 and in the denominator 8 into 0.09 into 50 is equals to 36. So when we divide it, we get this much of the seconds and we can convert it into hours by dividing by 60, then again by dividing by 60, it will be 28.305 hours. So option C is correct. Is this numerical clear to everyone?
Yes, ma'am.
Okay. So I'm moving to the next numerical. In a drying process, 4 tons of the sorghum is reduced from an 18% dry basis moisture content to the 13% dry basis in 1 hour. So determine the required heat for drying in kilocalorie per second and the necessary air flow rate in kg per second for the drying system. The given parameters are drying efficiency is 50%, latent heat of evaporation is 575 kilocalorie per kg, specific heat of the air is 0.24 kilocalorie per kg per degree Celsius, and drying air temperature is 44 degrees Celsius, ambient air condition is 25 degrees Celsius for dry bulb temperature and 20 for wet bulb temperature. We need to calculate here two things. First is the required heat for drying, and second is the what is the air flow rate of the drying system. So we have given the initial weight of the sorghum, or the total weight of the sorghum is given as 4 tons, and if we convert it into the kg, it is 4000 kg. The initial moisture content is 18% in the dry basis. Final moisture content is also given in the dry basis 13%. Drying efficiency of the drying system is 50%. Latent heat of evaporation is 575 kilocalorie per kg. Specific heat of air is 0.24 kilocalorie per kg per degree Celsius. Drying air temperature is 44 degrees Celsius. Ambient air condition is 25 degrees Celsius dry bulb temperature, and ambient air condition is 20 degrees Celsius wet bulb temperature. These are given in the question. So first, let's see that if we have the moisture content, we can calculate the the drying rate, the how much water is removing. So as per the formula, the moisture percent, it is given in the dry basis. So we are converting into the wet basis. So percentage moisture content is equals to what is the moisture content for the dry basis divided by the moisture content on the dry basis plus 100, and we are taking in the percentage, so multiply by 100. So the initial moisture content is 18% dry basis. So 18 into 100 divide by 18 plus 100, because this is 18. We have the moisture content already. We are just converting from the dry basis to the wet basis. So 18 into 100 divided by 18 plus 100. 18 plus 100 is 118. So 1800 divide by 118, which is 15.25%. So we have initial moisture content in the wet basis as 15.25%, and we know that the moisture content in the wet basis is equals to weight of the water divided by weight of the bone dry product plus weight of the water. So that means this is the denominator is the total weight of the product, the sum of the bone dry product and the water weight. So it is total weight, which is we are denoting as W. Weight of the water we are denoting as weight W as subscript as W into 100. So we already know that the from the calculation that our initial moisture content for the in the terms of wet basis is 11.25 is equals to weight of the water divided by total weight of the product, which is given as 4 ton or 4000 kg. So divide by 4000 into 100. So weight of the water is equals to 610 kg. When we multiply this 15.25 into 4000 divided by 100, so it will be 610 kg. So weight of the water per kg is, sorry, per hour is 610 kg. Now we know the weight of the water and we know the total weight of the product. So we can calculate the weight of the bone dry product per hour is equals to 4000, which is the total weight of the product, minus the weight of the water, which is 610. So it will be 3390 kg of the weight of the bone dry product. Now we have that was this formula we applied first for the initial moisture. Now this formula we are applying for the final moisture content. So percentage moisture content in the wet basis, the same formula we are converting the, because we have the moisture content of the final, which is 13% moisture content, but it is in the dry basis. So we are converting into this in the wet basis, which is moisture content or in the uh, dry basis divided by moisture content in the dry basis plus 100 into 100, because we are taking in the percentage. So 13 into 100, which is 1300, divide by 13 plus 100, which is 113. So when we divide this, we will get 11.504 percentage of the moisture in the wet basis as final moisture content. And we also know that moisture content is equals to weight of the water divided by weight of the bone dry product plus weight of the water into 100. So we know that 11.504% is the moisture content in the wet basis for the final moisture content, which is equals to weight of the water divided by weight of the water plus weight of the bone dry product, which is 3390 into 100. So if this 100 will go on this side, it will be 0.11504. Right? So this into multiply with weight of the water, then plus 0.115 into 3390 is equals to weight of the water. So weight of the water is equals to this term, which is when we multiply 0.115 into 3390, then it will be 389.85 divided by, this is 1. So when we shift this, so 1 minus 0.115, sorry, this will 115. So when we solve this, we'll get weight of the water is equals to 440.508 kg of the water is there when there is a final product after drying. This is the weight of the water. So amount of water lost during drying will be like initial, how much water was there in the product before? 610, right? 610 kg water was there previously. Now the water is in the product is 440.51 kg. So the loss is 169.49 kg per hour water is losing. So rate of heat transfer is equals to amount of the water lost during drying per hour into the latent heat of evaporation. So water is losing one with the speed 169.49 kg into the latent heat of evaporation, which is given in the question as here 575 kilocalorie per hour, and then if we multiply we get 97456.75 kilocalorie per hour, and if we convert this we will get like we can divide by 60 into 60 and we get 2707 kilocalorie per second. So rate of the heat transfer during air heating will be mcp delta T. So we know that the rate of the heat transfer is given we calculated 27.07 and equals to mcp delta T. So we don't know m value, we know cp value, which is the here specific heat of the air 0.24 kilocalorie per kg per degree Celsius. So we know already. Into T2 minus T1. T2 is temperature of the drying air, which is 44, minus the ambient air, which is minus 25. So 44 minus 25. And we know that the drying efficiency is 50% as per the question. So the left hand side is the rate of the heat transfer, which is we calculated 27.07, then equals to m mass into which is mass of the air or the air flow rate, which we need to calculate into Cp specific heat of the air multiply the temperature of the air, which is 44 minus 25, because the ambient air condition is 25 degree, into 50% of the efficiency of the drying system, which is 50 divided by 100.5. So when we calculate, so MA will be 11.87 kg per second. So this is the our option D is correct, which is heat we need around between 26 to 28, and then we need air flow rate we need to maintain around 11.8 between to 11.9. Is it okay?
Yes,
Is the
ma'am.
okay?
Yes,
So
okay, ma'am.
till now
But it's a
everything
bit
is
more
clear,
lengthy.
right? Yeah, this is a bit lengthy.
Very lengthy.
Like what variables we have chosen, we'll forget meanwhile.
Okay, so try with you, like try to solve by yourself once. It will be easy for you, because what we did in this whole question is first we have initial moisture content. So we from that we calculated what was the like when the product is not dried. What is its moisture? Then we did what when the product is dried, then how much moisture is there? And we subtracted that. That means we knew that this much of the moisture is lost. Then after that, we just applied the formula of heat transfer and we solved it. It's not very complex. So can we move to next question?
Yes.
So in column 1, we have the components or the system of a pilot scale freeze dryer system. In the column 2, we have its functions, like we have freezing fluid system, heating circuit, vacuum system and chamber. These are the components or the systems of a pilot scale freeze dryer. And in the second column, we have its function, like which is like defrost. Function is defrosting the condenser, product freezing, place for drying and evacuating air.
Option C, ma'am.
Option C.
Option C.
So
C.
yes, you are correct. Option C is correct. We have 4 major units in a pilot scale. Sorry, it's a scale. Freeze dryer. So the freezing fluid system, it can be sent to heat exchanger for the heat exchanger of the condenser or to the refrigerating coils for product freezing. Then second is heating circuit, which is like silicon oil heating fluid. So in that, for heating the plate and defrosting the condenser. And vacuum system is there for evacuation of the air from the apparatus before or during the drying process. And then we have chamber, which is bell shaped jar like this. Here is the system. And then with there the product temperature will, like the temperature is maintained at -45 to -50 degree, and pressure is very low, 0.05 millibar. Like this we have system. This is our usually the freeze drying system where vacuum pump is attached. It is evacuating the air. And here is a condenser system for cooling. This is the where our product is placed. And here is the vacuum maintained. Next question is, during the freeze concentration process, the fractional crystallization of water into ice and its subsequent removal is accomplished in a paddle crystallizer, wash column, melter, or heat exchanger. Freeze
Paddle
concentration.
crystallizer.
It's
Paddle
between paddle
crystallization.
crystallizer or wash column. There is a confusion between those two, paddle crystallization and wash column.
Okay, so can anyone clarify her doubt?
Paddle crystallizer whole setup, which includes wash column, melters, and other things as well. And wash column is only for removal of the ice only.
So she is correct that paddle crystallizer is the correct option. So what happens in the process of the freeze concentration? It involves fractional crystallization of water to ice and then subsequent removal of ice is done in the paddle crystallizer. And ice crystals, they are separating using the wash column, and melter and the heat exchanger, it removes or add heat to the system. Is it okay? Are you
Yes, ma'am.
yeah, so your doubt is clear, like wash column and paddle
Yeah,
crystallizer.
ma'am. Yeah, ma'am.
So let's move to the next question. Which of the following is correct sequence for the process of freeze concentration? Crystal nucleation, then growth, separation of ice, concentration, So we have four these operations. So which
Option
sequence
A.
is following? Option A.
Option A.
Right.
So everyone is on option A.
Yes, ma'am. So,
Yes. So it's very clear that it is our first. What happens? The ice crystal appears. So nucleation happens. Then it's the ice crystals. They start growing, and then there's subsequent removal of ice, and then the concentration of the product happens. Everyone is clear, right? In this, now let's discuss about something like some questions about the extrusion. So we have this image. In this image, we have A, B, C, D as our, like we need to tell about A, B, C, D part of the barrel or the screw of an extruder. So which is pitch, which is lead, which is flight width,
Pitch.
bearing width?
I think option C. B is the
Option C.
correct. Yeah. B
C.
is
Someone is saying B.
No, ma'am. C. C is the right answer.
Anyone else?
C is correct.
Option D is correct. Yes, option D is correct. This is the flight. A is flight width. This is the flight width, right? So flight width is width of the helical or spiral sections or the flights of the screw. These are flights, right? On the screw, these are flights. So its width is flight width. Then pitch. Pitch is horizontal distance of the corresponding points of the two successive lands. So this is the pitch. Sorry, this is the lead,
this is
not the pitch.
lead.
Yeah, this is not the pitch, this is the lead. So what happens? This is the difference. This is pitch and this is flight lead. This so so what is lead? Horizontal distance traveled by the material in one complete revolution of the screw when we are assuming 100% of the efficiency. It is equals to the pitch multiply number by the number of the starts. Number of starts means number of separate threads traced along the length of the screw. So this is lead. Then C, this one is land, which is the surface at the radial extremities of the square thread constituting the periphery or outside diameter of the screw. So this is the surface at the radial extremities. So we call it land. Then bearing width. This part is bearing width. So it is the width of the bearing supports that helps in maintenance of the alignment and rotation of the extruder screw within the barrel. So till now all the questions are clear for you.
Yes, ma'am.
So
yes, ma'am.
let's move to next question. Which of the
Ma'am,
Yes.
following
ma'am, can you please explain the pitch and lead in the diagram by labeling those areas of pitch and lead?
so this is like this one, two successive leads. See, this is horizontal distance of the corresponding points of two successive lands. So two successive lands means this is the land, sorry, this is the land. Like it's not a 3D picture, so it's like little difficult to make you understand. But like this is the land, so this part here is the land, right? So that it will be till from here to here, sorry, till here. But this is lead is between two threads, the surface, this surface. It is not including this flights. Can you able to understand?
Yeah, a little bit, ma'am, still.
Yeah, well, actually it's not 3D image. So it's
Actually, if I could recall, it was late wasn't explained in the video lecture as much I can recall.
lead is, yeah, it is explained. The definition I've taken from there itself.
Okay, then I shall look forward.
Yeah, but it's actually you try to find one YouTube, in YouTube you try to find a video, like 3D video, so it will be easy for you to understand. It mostly like, if these are flights, all these are helicals, right? It is in the form of, if you see, it's like a cylinder over which the helical helical these threads are there, like we
Structure.
see
Yeah.
in nail. Yeah, in nail we see that there is one cylinder, over that there are threads, right? So
Yeah.
if we include the distance of two, like this, if we include this thread also, then it becomes pitch.
Okay. Okay. Fine. Like
Yes,
including the threads, it's a pitch.
yes. Mm. Yeah, so can we move to next question?
Yeah.
Yes, ma'am.
Yes, ma'am.
Yes, okay. So, which of these statements are true regarding extrusion processing? Statement 1, about the fillers are commonly employed to enhance the expansion ratio of extrudates. Statement 2, the addition of plasticizers can regulate the degradation of starch. Statement 3, emulsifiers are used to prevent the processed mass from becoming sticky. So,
1 and 3 are used. But second one, let's decide.
this is like very minute difference, and we need to tell which is true.
It's I think 1 and 3.
C.
Option C.
Anyone else? Anyone?
D.
So one is saying B also. So who is saying B is correct? But can you tell me why you are saying that statement was one is incorrect? Very minute like difference is there. So B is correct. So fillers, they are basically are the one which are added to the polymers or the base materials to modify their product properties and sometimes to reduce the cost, and they are generally used to decrease the expansion ratio, not enhance. It decreases the expansion ratio. So expansion ratio means what happens when we are using the extrusion, and when the product is coming out of the die, then its volume gets increased. When it exits the die or it cools down, it swells, right? Mostly we use polymer, so we use a term known as polymer swell because of the change in the pressure inside the extrusion, like the here this is the extrusion, so extruder. So what happens when this extruder here, it's here in this here it is in the high pressure compressing, and when it goes out of the die, what happens, the pressure suddenly comes to the atmospheric pressure. So there is a from high pressure to low pressure, the products come out, so it swells. So also, like it decreases the expansion ratio, the fillers they decreases the expansion ratio because they increases the density and they reduces the gas or the foams, and because they are like increasing the density, the viscoelasticity or viscosity of the product, it gets changed, and sometimes it forms the bonds like hydrogen bond or make form cross linking. So there will be more structural integrity. So because binding is more, so the internal forces are so high, that like little bit high, that it tries to decrease its expansion. So its expansion ratio decreases. Second is degradation of the starch. It can be controlled by adding of the plasticizers. Like we plasticizers are those like we use some additives in the like maybe polymer processing. We add plasticizers like glycerol, sorbitol. So they are low molecular weight compounds and they can be incorporated to increase the flexibility or the softness of like what plasticizer does basically. This is the polymeric chain. This is also a polymeric chain. It is like highly cross-linked and like very, there are many, and so plasticizers goes in this space. So the bond will be little less tightened now, and that's why the chain like it increases the chain polymeric chain flexibility. So usually what happens when we add plasticizers, it change the um, behavior of the starch or the gelatinization behavior of the starch. So the degradation of the starch can be controlled by adding certain amount or like if we specific amount of the plasticizer. So the it can be the properties can be modified. Emulsifiers, they are the one which reduces the surface tension. So like we have lecithin as a emulsifier, and they mix the two immiscible liquids so well that the agglomeration is not there and the mass will not stick, the stickiness will go. So option statement 1 is incorrect, statement 2 is correct, 3 is also correct, B is true. Is it okay?
Yes, ma'am.
Yes, ma'am.
Thank you. Let's see another question. From the figure provided, choose the correct sequence for the size of the die. 1, 2, 3, 4. We have dies. From this figure, we need to tell which die is small, which die is in the size, which is large.
Option A.
Yeah,
Option
correct,
A.
ma'am.
Yes. So anyone, please, can you explain logically what is happening in this diagram? You are correct that option A is correct. What is happening? On x-axis, we have pressure. On y-axis, what we have? We have the
Resistance.
moisture.
I'm not sure.
So what is happening actually? On the x-axis we have pressure. So here the pressure drop. Pressure drop means when the product is coming from inside to outside, then how much in the extrusion. So how much pressure is decreasing. So like we have different dies. Based on the dies, the pressure may vary. Like uh, uh, the size of the die, based on the size of the die, we can control the pressure. If the die size is like here it is saying that the pressure reduced is more, right? The pressure dropped increases as the size decreases and throughput increases. So when die 1, it is saying that low resistance. So die 1 here, that means the pressure reduces low. So if pressure is reducing low, that means the size of the die is more, right? And when die 4 is saying restrictive die, because its size is very small, because it is dropping the pressure, very high pressure it is dropping, like the pressure gradient is very high. So that means the die size is very small. So die 4 is of very small size. If there is maximum throughput, means there is no pressure build-up, means all the product like uh, there like there is a die which is open discharge. We say this condition as open discharge, where there is no pressure build-up and the maximum throughput is there. So that means there is no die. But when there is another condition called closed discharge, in which the extruder is plugged, so where the maximum pressure is built up and there is no throughput is coming out of the from this barrel, and from this die no throughput will come out, because it is closed. So it is closed discharge, there is no opening here. So here there will be more pressure and no product will come out, so throughput will be 0. While in the case of open discharge, it is like from barrel, uh, there is nothing here, so all can come out. So throughput is high, but also and no pressure is built up. So this is called open discharge condition. So that means if we have the die which is of lesser size, that means the pressure buildup is more, right? So we have option A as correct. Die 4 size is the smallest because the pressure is higher. Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay, ma'am.
So second, the another question is the area in an extrusion where there is amorphization and texturization of the product happens. Which zone is like the feeding zone, cooking, kneading, or the feed hopper, where the amorphization and the texturization of the product happens. Amorphization means that a product is like from the structural phase is changing from the crystalline
Zone.
solid to the amorphous, which is the lack of any range, like any order. So the product, when it is converting from crystalline solid to the amorphous, it is known as amorphization. And texturization means when we apply the some like mechanical pressure or force or structurizing agents, then the structure of the product it changes, like its properties, its functionalities becomes better, and also results in the formation of new texture products due to the interaction between the food components. So these two terms indicate that the overall the product uh, texture or its structure is inside, uh, like it's changing. So in which zone it happens?
Ma'am, kneading
It
zone.
might be cooking zone. It might
Cooking,
be.
cooking zone.
Someone is saying cooking and someone is saying kneading. We have two options. But cooking zone is the correct one, because what happens in the feeding zone, what happens where we have the product is like we get the product, and it is like little bit mixed up, but like just we get the product here. So feeding zone is a area where preconditioned low density particles of the raw materials are introduced in the barrel. Second is our kneading zone, which is also known as the compression zone. This is the first one is the feeding zone, and compression zone, where the compression of the material happens and the flow channels of the extruder achieves high degree of fill as their volume and screw pitches decreases. And in C, which is the like the cooking zone, where what happens, there is increase in the pressure and the temperature, and because of the higher shear rates, there is the structural changes, which is amorphization and texturization of the product happens. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So let's move to the next question. That common type of material movement within the barrel of an extruder: drag flow, pressure flow,
All
and
three.
leak flow. All three.
All three.
All
Everyone.
three, ma'am.
So yes, all three we have drag flow, pressure flow, and the leak flow. Drag flow is the flow of the material inside the barrel due to the action of dragging. Pressure flow is the reverse flow of the material in the screw channel, and leak flow is the reverse flow through the clearance. We can see this first one is drag flow, pressure flow, leak flow. So what is happening here? This is a barrel wall. So the product which is touching the barrel wall, it will have the highest velocity. After that, the velocity will go down. So this is because of the screw. It is like dragging. So it's drag flow, and pressure flow is it's like here. So what happens here? It's the reverse flow, which is because of the pressure, the product starts flowing at the backward direction. And leakage flow, when it's near the this threads or the pitch, sorry, or the threads or the flight. So some product starts when it is like in the helical movement, it is rotating. So some starts leaking from here. Some product will go here. So through the clearance it goes. Here in this we can see clearly. It is more better picture. So the person who was asking pitch. So pitch includes this, like this area, this area plus this flight. So this is pitch. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes.
So now let's talk about extruded products which are made from fish. Which is the extruded product made from fish? Anyone?
Ma'am, A.
A. Yes,
It
A.
looks it's me.
So it is actually the extruded fish scraps and fish which are not sold in the fresh market. So they usually are made to mimic the costly fishes. And sometimes we use soya meals and other vegetable proteins to make the meat extenders or meat analogs. So we know that sometimes we say that the vegan meat are new concepts in the market about plant proteins, or sorry, plant based meat. Anyone heard about this vegan meat? So
Yes.
yes, right.
Yes, ma'am.
Anyone tried? Anyone tried this product? So next time when you go, please check the ingredient list in the meat analogs or the meat, like the plant-based meats. What are the products they use? So mostly they use the soya proteins or other vegetable proteins to mimic the animal meat and form the same, like it they use binders and other additives to make its mouth feels similar and its taste similar as the meat. And then we have the fig newtons, which are the basically the cookies which have the fig paste. So they are usually made from the extrusion process. And another is liquorized. They are basically shiny semi-firm gelled candies. They are made from the liquorized fruit extract, and they are also made from the help of extrusion process. So we have option A, surmi is the correct answer, which is the product made from the fish, and we extrude it and we try to make like similar as costly fish products from this. So next is the which of the following statement is incorrect with respect to extruded products. So extruded products absorbs moisture more rapidly with waxy starch. Semi-moist foods can have their water activity reduced using high modified starches. Starches can result in greatly expanded product that has a very mild flavor. Shrinkage in extruded meat products can be decreased by using modified starches. So we need to tell incorrect statement.
A.
A, we get the answer A. Which is correct also. So what happens? Waxy starches, they reduce the rate of moisture uptake in the extruded products. So which keeps the cereals and the pet foods will not become soggy when they will be in bowl. So whereas it is saying that absorbs the moisture more rapidly when we add waxy starches, whereas waxy starches prevent the moisture uptake. So option A is incorrect. The starches, like we have the highly modified starches. So highly modified starches and dextrins, they basically use to reduce the water activity in the semi-moist foods. And the starches, they can give highly expanded products with the bland flavors suitable for mixing with delicate flavors while not masking them. And the modified starches, they trap or bind the fat into the extruded meat products, which reduce the shrinkage problem. So option A. So as far as is it clear?
Yes, ma'am.
So
Yes.
let's solve question on the extruder. So we have twin screw extruders. So twin screw extruders, they can be counter rotating or the co-rotating. They can like rotate both the screws, they can rotate in the clockwise direction or they can rotate in the anti-clockwise direction. So we can say co-rotating. If they are rotating, one is in the anti-clockwise direction, one is rotating in the clockwise direction. So that means they are counter rotating. So what happens in the what is happening in the twin screw extruder? We have rotation speed 9 revolutions per second. Average pitch width 0.04 meter. Helical angle is at 25 degree. Screw length 1.2 meters. Screw tip diameter is 0.06 meters. Average screw height 0.003 meter. And melt with a average viscosity of 6 pascal second and is introduced at atmospheric pressure. The pressure at the die is 1.55 megapascals. We need to calculate extruder's volumetric output flow rate. Please try to solve this question. So we have speed of rotation as 9 revolutions per second, average width of the pitch W as 0.04 meter, average screw height H is 0.003 meters, length of the screw L is 1.2 meters, angle of helix is at 25 degree, screw tip diameter is D equals to 0.06 meters, average viscosity of the melt is equals to 6 pascal second, pressure at the die is 1.55 megapascals. So extruder's volumetric output flow rate we need to calculate, which is V. So volumetric output flow rate of extruder V is equals to, we have this formula which is pi into D. D is screw tip diameter. N is the revolutions per second. Cos theta. Theta is the angle of the helix, which is 25 degree here. Then into H into W, which is the average screw height into average width of pitch. Divide by 2 minus delta P, which is the pressure at the die, into W, which is the width of the pitch, into H. H is the average screw height, H. Its cube we will take, divide by 12 into mu, which is average viscosity of the melt, into L. L is the length of the screw. We have this formula and we have every value is already like given, which is pi, which is 3.14. We know 3.14 pi into D. D is given as 0.06 meter into N. N is revolutions per second, 9 revolutions per second. So 9, then into cos theta. Helical angle is 25 degree. So cos 25 into H into W. So H is given as 0.003 and W is given as 0.04. Divide by, this whole is divided by 2 minus the pressure at the die, which is 1.55 megapascal. So mega means 10 to the power 6 pascal. So 1.55 into 10 to the power 6 pascals into W, which is given as 0.04. and H cube, which is 0.003 cube. Divide by 12 into the average viscosity of the melt, which is 6 pascals second, into L, which is 1.2 meter. So we will solve this. 3.14 into 0.06 into 9. This 3 will gonna give 1.6956, this value, and then cos 25 is 0.9063. Multiplication of this will give 0.00012 divided by 2 minus 1.55 into 10 to the power 6 multiply 0.04 and 0.003 cube is 27 into 10 to the power minus 9. Divide by 12 into 6 into 1.2, which is 86.4. So V is equals to, this whole can be solved and the value will come as 9.22 into 10 to the power minus 5 minus this whole, when we solve, it will give 1.9375 into 10 to the power minus 5. So when we minus this, we will get V is equals to 7.28 into 10 to the power minus 5 meter cube per second, which is our option B. Is this question clear?
Yes, ma'am.
This question is clear to everyone.
Yes, ma'am.
So let's move to next question. In the process of preparing meat analog via extrusion texturization process, the pH of the conditioned defatted soya flour or the soya grits fall within the range of the pH.
Option B, 4.5 to 5.5.
Option B, 4.5 to 5.5.
C.
Yes, C is correct. So what happens? The defatted soya flours or the grits, they are conditioned to approximately 20 to 40% of the moisture, and pH will be 6.5 to 7.5, using appropriate acidic or basic salts when we are preparing, it for the meat analog. If there is pH less than 5.5, then the extrusion process, it will be difficult and the product will be tough. If the alkalinity is very high, which is like more than 8.5, then the product will become very tender, less chewy, and absorbs more water, and the taste will also be influenced because there is high alkalinity. So we mostly take 6.5 to 7.5 as the pH. Let's solve another question on the extrusion. So the corn meal, we are having corn meal which is having moisture content as 16% wet basis. We are feeding it through the metering zone, we are feeding of the extrusion, and then we have the channel dimensions as 5 centimeter width, 2 centimeter height, 50 centimeter length. The wall velocity is 0.3 meter per second, and the extruded, it has the viscosity of 66,700 pascal second. The density is 1200 kg per meter cube. The pressure drop is 3000 kilopascal. We need to calculate volumetric flow rate in meter cube per second of the, which is flowing through the cross section of the channel. So since we have given that the moisture content of the sample is 16% wet basis, channel width is 5 centimeter, which is 0.05 meter, 2 centimeter height, channel height is 2 centimeter, which we can convert into meter as 0.02 meter, and 50 centimeter is 0.5 meter length we have converted here, which these parameters are given. Now the wall velocity of the material velocity which is in the touch with the wall is 0.3 meter per second. Viscosity is given in the question as 66,700 Pascal second. Density is 1200 kg per meter cube. Pressure drop is 3000 kilopascal, which is 3000 into 10 to the power 3 Pascal. So we need to calculate the volumetric flow rate through the cross section of the channel. So the formula is V equals to the velocity of the material which is in touch with the wall into H, which is the H into W, which is the channel height and the channel width, divide by 2 plus delta P, which is the pressure drop into W into, which is the channel width into channel height cube, divide by 12 into viscosity into the length of the channel L. So everything is given, we just need to put in the formula. So the wall velocity is given as 0.3 meter per second into H is 0.2 meter and W is 0.05 meter, divide by 2 plus pressure is 3000 into 10 to the power 3 Pascal. W is 0.05 into H cube, 0.02 meter cube, divide by 12 into the viscosity, which is 66,700 into L, which is the length of the channel, which is 0.5 meter. So this 0.5 meter. So when we multiply 0.3 into 0.02 into 0.05 and divide by 2, we can get this value 0.00015 plus. So this term is like when we multiply the when we solve the numerator, we get 1.2 and the denominator it will be 400 So we can write this as 1.5 into 10 to the power minus 4, and this part which is on the right side we can write it as 0.02998 into 10 to the power minus 4. When we sum, it is like around 0.03. We take it as round off. So V equals to 1.5 plus 0.03, which is 1.53 into 10 to the power minus 4 meter cube per second. So option A is correct. Is it clear?
Clear. Clear.
Excuse me, ma'am.
Yes.
It is very challenging to memorize all these formula for examination purpose.
Mm, but we need to like this formulas we need to
Exactly,
like
that's happening. Like while doing, it's very difficult to remember all the formulas and like completely new terms.
but like mostly we need to like learn the formula because uh, it's very like it's very rare that we can get the formula in the question paper. So you can connect these formulas like previous formula, it's almost same, right? This term is almost same. Here just some variation is there. So you can like memorize what. I know these are very lengthy formulas, but if you like practice many times, then it will automatically stick to your head. I believe so.
Actually, it is like if we'll practice so many times, it's still
Yeah, I know that these extrusion formulas are a bit lengthy.
like it consumes more time to solve one question, like each questions.
The question will not take much time because these are very direct questions. If you know the formula, you can just directly put the value and get the answer. While if you see in other cases, they are not the direct questions, right? Like you need to think, solve some steps, and then you can apply the main formula. But here in extrusion, mostly you'll get direct, like the direct formula you need to just apply and you can solve.
Okay, ma'am. Next question, ma'am.
Yes, like because obviously, like mostly more like most cases, the formulas will not be there in the question paper. So okay, so last question for today. Among the given plant proteins, which one offers the most effective gelling properties? Wheat gluten, soya protein isolate, pea protein isolate, or mycoprotein?
Jailing bit
Most
gluten.
effective gelling protein. So gluten is the correct answer. So we have the gluten, which is protein made from the gliadin and glutenin. So these two proteins, they will go and under the 3D structure, and when we put some water and knead it, they these two different proteins, gliadin and glutenin, they form 3D structure by making like the hydrogen bond or the disulfide bond, and they form 3D structure which provides the gelling property. Like because of that, there is development of the layered fibrous structures, and it helps in the when we make in the meat analog. So this is like the last question. So topics we covered like today is about freeze drying. We discussed about fundamentals of freeze drying, heat and mass transfer in freeze drying, then the components of the freeze dryer, then types of the freeze dryer, and then we discussed about the food extrusion technology, about the twin screw extruder, like the geometry, about different pitch lead, and about different terms flight, and we discussed about the how the material flows through the screw and the die. There are different flow like drag flow, pressure and leakage flow, and then extruded products. We discussed about the meat analogs and extruded meat or the soya products. And in the next week, we will discuss about aseptic processing and packaging, hurdle technology, natural antimicrobials, and food lipids, nature and its occurrence. Also, in the last class, we have one doubt regarding co-solvent, which were at the like end of the class. I also like posted the same in the discussion forum. So co-solvents, if someone is not there in the discussion forum, so we are discussing now. So co-solvents are the solvents, they are added to the primary or the main solvents to increase the solubility of the system. Like in the supercritical, CO2 has a dissolving property similar to hexane, which is the non-polar materials. and a small amount of the co-solvent sometimes we add to increase the ability of the supercritical CO2 to dissolve the polar compounds. Co-solvents which are like added, which are with the methanol or the ethanol to reduce the viscosity of the oil, and the co-solvents can also use to modulate the hydrophobic effects. So this was the last class doubt. So after this lecture, I'll be uploading the lecture
Ma'am,
video.
I'm having a doubt.
Yes,
Some assignment for question number 2,
assignment
answer
4, question number
question
2.
number answer is already there. Still, I'm missing something, so I'm not getting well that.
What is the question? I have not actually checked question.
Uh, it is. It's a numerical only. The induction of radioactivity.
Okay. So, uh, so what is like the problem? I can note down. So, assignment 4, question 2, problem is
Yeah. Problem is like in the solution part only having doubt, some little doubt, ma'am.
solution part.
Yeah.
So,
It's there in answer, ma'am. Just not getting somewhere something. I'm missing that.
okay, some part you are not able to understand, like the solution part you are
Yeah.
not able to understand, right?
Yeah.
Yeah, I'm opening that. This year's like this one. So this one, right? Let's
Yes, ma'am.
see.
Solutions. Yes, ma'am. Two number.
Determine the yes, determine the required thickness of lead to absorb 99.89% of gamma radiation energy with an incident photon energy of 4, and we use the extinction coefficient of the lead. I note is 100, then 100 minus this coefficient I equals to I naught. So, like, what is your doubt in this?
That there I upon I naught should be 0.0011, right?
I by I naught is 0.11.
0.0011, because
So, it is
0.11 upon 100, so it would be 0.0011.
I naught is 100, I is 0.11. Yes, yes. So,
Yes.
it will be 0.0011. Yes,
Okay. After
0.
this, like how to solve, ma'am?
Okay, so after this step, you are asking how to solve?
Yes, ma'am. And it's written there 0.0001, so I got confused.
Hmm.
Like, what would be the answer?
So it is 0.0011 actually.
Right. Yeah.
Hmm. So here we will take ln both sides. So it will be ln this one and ln this.
0.0011.
So this will come as ln, if you solve ln 0 this one. So how much you get? Let me open the
0.5.
calculator.
Yeah.
So ln 0.0011, right? So it will be
Yes.
minus 6.81.
Okay.
Let's see. Mm,
6.81 upon 0.58.
this is like ln. We had ln 0.0011
1 1.
equals to minus
minus 0.58x.
0.58, right?
Yes, ma'am.
0.58 minus 0.58x.
Yes.
So, yes, 0.58x. So, it will be minus 6.8 because ln 0.0011 is minus
Minus
6.881
6.8.
divided by 0 minus 0.58, right?
Okay. Yes.
So, what is this? Divide by minus 0.58. So, we get 11.74 or 75, whereas
It is
answer is
15.88 centimeters. When it is converted into meter, it
because
is.
it is taking this one, because it is taking this value. So if we say ln 0.0001, so it is minus 9.2 divided by 0.58. Yes, so it is considering this as value. So little mistake is there in the calculation part.
Okay, that means it is the option that answer was not there, right?
That is what I'm seeing. That in the four options, the answer is not here.
Yes, ma'am.
The options are also yeah. So it will be reconsidered, no problem.
Okay, ma'am. And with that, like the log values of this 0.0011, like how will remember those things during exam if it
Because
is
you can use maybe scientific calculator for that.
whether it is allowed in the exam hall.
Can you put this message on the Google in the discussion forum? This
Okay,
that is
ma'am.
a scientific. Yeah, please do so.
Okay, ma'am.
Ma'am,
And can you once again share the link for discussion forum?
I have already shared in the chat box.
I'm not able to get it.
ma'am, one thing.
Yes,
Ma'am, is exam or in offline or online, ma'am?
please post this also on discussion forum. I have repasted the. Can you now access? Please,
Yes,
can you
ma'am.
ask these questions on the discussion forum so everyone will like one time answer can make everyone like everyone know what actually the you have the same query like other people, so everyone will be able to get the answer.